السلام عليكم ورحمة الله.
Hello.
وعليكم السلام.
وعليكم السلام.
عليكم السلام.
أهلا شباب. Please open your camera. شباب شباب open your camera to communicate with me.
Okay.
Welcome Ibrahim. Today we'll make a revision about the forces, balanced force and unbalanced force, and start with Newton's second law. Okay. The formula of Newton's second law, the mathematical formula of Newton's second law, is F equal ma. F refer to resultant force or net force. Okay, and m symbol of mass of object. A is the acceleration. What is the statement of this force, of this law, which relate the resultant force and the acceleration of any object? Who can answer? What is this relation, or what is this statement of this Newton's second law? Huh? Ahmed Hussam, can you answer?
Yes,
Please tell me what is the statement of Newton's second law.
the acceleration of a body is directly proportional to the net force acting on the body, provided the mass remains constant.
Excellent. Thank you. This means the acceleration of object is directly proportional to the net force which applied on this object. Okay, what is the measuring unit of the acceleration? Farah?
Meter per second squared.
And the measuring unit of mass is kilometer. This means the Newton as a measuring unit of force is equivalent to kilogram meter per second square. Okay?
Okay.
Okay.
Now we will discuss different forms or different phases of the applied force. What is the effect of the net force if this net force or resultant force equal 0? If the net force equal 0, this means all forces which act on this object, okay, the resultant of this forces equal 0. But what, in this case, what is the effect of these forces on object? In two situations. If this object is moving, what happened? And when this object at rest or a stationary object, what is the effect of the force? Who can answer? Ibrahim, what is the result or what is the effect on the object when this object, stationary object, when the net force equals 0?
When the net force equals 0, it will remain apply a force.
It will remain apply the force, or you mean this object is still at its state without changing in its state.
Yes.
Okay. Oh, this is the statement of Newton's first law, which said when the resultant force which applied on the object equals 0, okay, the object is still at its state without it changing. If this object at rest, it will continue at rest without it changing to moving state. And when this object is moving object, okay, or in state of moving, okay, it will continuous in moving with constant speed. This means when the net force or resultant force which applied on the object balanced or the net force equal 0, this means the moving object will move with constant speed. Do you understand?
Understand.
Okay. Different example for this case when the effect of the resultant force equals 0, like in this caricature with this moving car. This moving car, there is two forces act on it. The first one is the force of engine, of the force of motive force. This force from the car engine. This acts toward the left, like you see from the direction of the arrow. And another force which acts on this car, which acts in opposite direction, which is friction force. Friction force. If you look at the size of this arrow, of these two arrows, you will observe the size of two arrows are equal. Like what this information indicate? When the two sides of these two arrows equaled, this means
the net force is 0.
Okay, the net force equals 0, but now I ask about
balanced force.
Yes. When the two arrows equal in size, this means the magnitude of these forces are equal. Okay, the first the magnitude are equal, but and the direction of two forces act in opposite direction. This means that these two forces are balanced. What is meant by balanced? This means each one cancel the effect of the other, so that we say the net force act on this moving car equals 0. So that this moving car moved in constant speed. Okay?
Okay.
Like in the second example of stationary science book. This book remained constant without a change to moving. Why? Because the net force on this book canceled each other, so that the net force equal 0. The second effect of the net force is this effect of positive net force. Let me say, we suppose the motive force direction is a positive direction, and the resisting forces is negative direction. I mean, the motive force which causes the movement is the positive, and all types of resisting force is a negative direction type. Who can tell me what are kinds of the resisting force?
Can you say the question again, teacher?
Oh, give me example of resisting force. Resisting force means the forces which oppose the direction of motive force?
If there's a heavy object, if you're pushing a heavy object, you will be consequently the force will be less acceleration, and you'll be
ها فرح أحمد. Give me example of this resisting force. Resisting force like friction force, air resistance,
Air drag,
or
drag force.
yeah, air resistance called drag. Yes, yes. يبقى all the resistant air resistance, water resistance, and friction resistance, friction force, all of these forms of forces which oppose the direction of motive force, okay, and reduce the speeding of object, so that we say this this force is called negative forces. Look at this example. We have truck. This truck moved with motive force, and there is two forces opposed this direction of force, like air resistance, okay, and air resistance and the friction force between the tire and the road. When the motive force is greater than the friction force, what happened in this case? This car will move with acceleration or deceleration?
It'll be moved with acceleration, which
Yes.
that because
Yeah.
the inside of the car is pushing the force. It's
Great.
like when you're pushing a gas, and then the car will accelerate.
Yes, yes. Great. When the motive force is greater than the friction force or resisting force, in this case, the object move with positive acceleration, or we say the object will accelerate. Okay.
Okay.
What happens when the resisting force is greater than the motive force? This object will move with acceleration or deceleration?
I can believe it's deceleration.
Of course, deceleration. Of course. Excellent. But when the net force is negative, this means the resisting force is greater than the motive force, so that the object will move with deceleration, or we say the object will decelerate. The fourth type of the forces which act perpendicular to the direction of motion. The best example to illustrate this effect of this force, the motion in circular path. When the object move in circular path, like when you hold the thread, and try to move this thread, okay, this thread will move in circular path. What is the effect of the force which acts on this thread or the pole at the end of this thread? When you hold this thread, you will affect by force named centripetal force. Centripetal force. This force keep the object to move in circular path. Okay, the centripetal force keeps the object to move in circular path. Okay, what is the direction of this force? and what is the effect of this centripetal force on the velocity of this moving object. Look at this example. This train turning to the left, or in a move in circular path or semicircular path, okay? The force is either driving or resisting. It acts as a centripetal force, which is inward force needed to make the object to move in circle. The direction of this centripetal force all the time toward the center of this circle. Look at the drawing which indicates the moving of this pole in the left side of the page. This pole move, okay, with velocity. This means it change its direction, okay? But when you look at the black arrow, which indicate the direction of the centripetal force, you will observe this force act toward the center of this circle of this path. Okay, so what about the direction of velocity at any point of this circular path? What is the relation? I will repeat my question. What is the relation of direction of velocity and the centripetal force at any point of this circular path? Huh? Who can answer?
They both are vectors.
Please raise your voice, Ahmed.
Both of them are vectors.
I see both of them are vector, but I ask about the direction of each one. Okay. Look. This is the circular path. And this is the center, okay? And this is the moving object. We say the centripetal force of which keep this object move in circular path act all the time toward the center. So that's the direction of centripetal force in this direction, FC. Centripetal force. And according to Newton's second law, we say any force which acts on moving object cause this object to move with acceleration, okay, in the same direction of this force, okay? If I ask you what is the direction of the accelerations for this moving object, you will answer with at any direction.
At any direction depends. Yeah. If you got you have the following in problem solving.
Another answer?
Downward.
Down.
Yeah. I ask, tell me the direction. Okay, I will ask another question. The direction of this acceleration, okay, will act in the same direction like this or in opposite direction? Farah?
Yes.
I ask about the direction of about the acceleration. It will be in the same direction of centripetal force or in opposite direction? Or in this direction? Tell me as you understand. Don't afraid from the answer. أحمد طيب.
Maybe it will turn.
It will?
It will turn.
I can't hear you. Please raise
Maybe
your
it will
voice, please.
turn.
Turn?
Yes.
Okay. The direction of the acceleration in this case in the same direction of centripetal force, like this arrow. Both of them act toward the center of the circle. Type. What is the type of this acceleration? This acceleration will be linear acceleration or non-linear acceleration?
Linear.
Linear?
Mhm.
No, no. This is non-linear acceleration.
Miss, what's the difference?
What?
What's the difference?
Difference between linear acceleration and non-linear acceleration. Linear acceleration, which is called the movement in a straight line with the changing of velocity with the time. But in this case, the object move in circular path, so that the acceleration which you move with it is non-linear acceleration. Okay? What about the direction of velocity? Velocity of this moving object at this position. Velocity. What is the direction of velocity? No answer? Explain? Okay.
Yeah, explain.
What is the matter with you?
No, nothing.
Okay. Listen to me. In the motion of circular path, the object at any position like this or at this position, any positions of this circular path, the direction of velocity all the time and perpendicular to the direction of centripetal force. What is meant by perpendicular? Perpendicular means they make a 90-degree angle with the direction of centripetal force. This means this vector which represents the velocity is tangent of this circle at this point. Okay, type. What about the direction of velocity at this point, like this? And the direction of velocity in this position. Okay, yes. And that according to, pay attention, according to the direction of motion. If this moving object move in this direction, means anti-clockwise direction, okay? The direction of velocity, like in this example. Farah, do you understand me? Huh? Farah, Ahmed, any problem? If you don't understand, ask me to repeat this point.
Yeah, can you please repeat it?
Okay, I will repeat that. I say in the motion, in the case of motion in circular path, okay, there is the force which act on this moving object called centripetal force. Okay, this centripetal force acts all the time, and at any position of this moving object act toward the center of this circle. Okay, do you understand this point?
Understand?
Yeah.
Okay.
Yes.
Then I ask, what is the direction of acceleration which is the moving object to move with this acceleration? I say the direction of acceleration in the same direction of centripetal force. Okay, now we say both of centripetal force and the centripetal acceleration, both of them act toward the center of this circle. Understand till this point?
Okay, understand.
Okay. Farah?
Yes.
Okay. After that, we ask about the direction of velocity of this moving object. Okay. I say in this point, for example, the first example, at this point, the direction of centripetal force and the centripetal acceleration represented by these two arrows which directed to the center of this circle. And the velocity of this moving object, its direction, like this, perpendicular to these two vectors. What is meant by perpendicular? Make the right angle or 90-degree angle with two forces. If we redraw these two vectors, I will make that. At any point on the circular path, the direction of centripetal force and the centripetal acceleration act toward the center of this circle, and the direction of velocity like this vector, which is perpendicular to each one of these two vectors. فهمتيني يا فرح؟
Yes.
Okay. I will ask you questions to ensure you understand this point. If I ask you to find the object at this point, tell me the direction of centripetal force and velocity direction. You can draw. Farah?
I don't get it.
I can't hear you. Please raise your voice, please.
I don't get it.
Farah, tell me. Farah?
Yes.
Tell me the direction of centripetal force. Its arrow toward to the center or out of this circle?
Out.
Toward the
Out.
center? Like this?
Out.
Great. Type, what about the direction of velocity? Ahmed? Ahmed?
Yes, yes.
I'll draw the direction of this vector of velocity. Make this vector to in this direction, okay, or in this direction?
The first one.
First one, great. Why? Because the direction in this direction, the motion in this direction, so that the velocity vector will represent by vector perpendicular to the centripetal force. Okay? Any problem?
No.
And Farah, Ahmed?
No.
Okay? Alhamdulillah. For this car moving around circular path, what provides the centripetal force? In this question, ask about the centripetal force results from what? The answer is sideway friction exerted by the rods on the tire. يبقى if the examiner asks you to answer the what is the resource of this centripetal force, يبقى this force results from the friction between the rods and the tire. Okay. Second question, which object can have a steady speed but change the velocity? Steady speed, but changing the velocity. An object which move in circular path. يبقى this means, pay attention, this means any object move in circular path, okay, moved with constant speed, but changing velocity. I mean changing the direction of the velocity. Do you understand? Okay.
Understand.
Yeah. What accelerates toward something yet never get close to it? What is meant by this question? يسأل عنه. يعني بيقول لي عارفين yeah.
It might be like if you're rotating too hard, but like trying to accelerate, then the force will apply, and the vector will be a vector.
Okay, I ask about the understanding of this question. This question asks, can any object or moving object affected by the acceleration, but without touching with this force? Of course.
Of course.
Yeah, like in this example, when the object move in circular path, they may affected by centripetal acceleration due to centripetal force which acts on it. Okay. In some situation, we need large centripetal force. Like number one, if the mass of object is increased, like do you think the centripetal force which affect on a small car like the required centripetal force which affects on a huge truck? Do you think both of them are equal?
Actually, no.
Of course, no, of course. Farah. Farah?
Yes.
Do you understand me?
Yes.
The second situation, if the speed of object is increased, this means we need to increase the centripetal force. Number three, if the radius of circle is reduced, so that if you move on the roads, on the ring roads, in some places or some portions of this ring road, it is a very small radius, so that it required from us to move slowly, relatively slowly, okay, so that all cars which move in ring roads, okay, move slowly in the curves of this road. Do you understand?
Yes.
يبقى the three conditions which need large centripetal force. If the mass of object is large or increased, if the speed of objects increase, if the radius of circle is reduced. So that's all engineers who designed the ring roads, okay, book all of these conditions in their consideration to design the road which is suitable for different conditions. Okay, I think they designed all these rings roads at the maximum difficult condition. Okay, now try to answer this question with us, okay? Number one, Ibrahim, try to answer. Which statement about the mass of an object is correct?
Which statement about the mass of an object is correct?
Please repeat, what do you say?
I just said the question.
Yeah, like what about the answer?
The answer, let me think. The answer is it's equals to the y multiplied by the gravitational field strength, the B.
P. You mean the mass equal to the weight multiplied by gravitational field strength?
I just it's a B answer. It's a B answer.
P answer? No. Okay. You said the mass of object equal to the weight multiplied the gravity strength. No, this is wrong.
No.
Wrong.
Can I answer?
Ahmed?
Yes, D. The property
D?
that resists a change in velocity.
Of course, D. Why? Because according to this relation, Ibrahim, pay attention. According to this relation, weight equal mass times the gravity strength, G, not vice versa, okay? And when I ask about the mass according to this equation, okay, the mass equal weight divide the gravity strength or gravity acceleration. But the right answer is the mass doesn't change with the changing of velocity. By the way, mass from the physical quantities which doesn't change at any condition, okay? But when you look at this equation which represents the weight of objects, we say the weight of object change according to the value of gravity strength. So that the weight of my weight on the Earth planet is different than my weight on the moon or my weight on the Jupiter planet, for example. Why? Due to difference in gravity strength or gravity acceleration. Okay? Do you understand? Okay. Farah?
Yes.
Yeah, this question, a person step on the bathroom scale. Bathroom scale record both mass and weight. Which row show the reading on the scale?
B.
Of course, great. Mass equals 60 kilogram and weight equals 600 Newton. Because the weight equal mass times gravity acceleration means 60 times 10 meter per second square, so that weight equals 600. Okay, Ibrahim?
Yes.
The object has a weight of 7,600 Newton and the gravitational field of strength 100 Newton per kilogram. Okay, what is the mass of this object?
The mass of an object.
Yes.
The weight of the mass. So this question has it mentions 7,600 newtons and has a gravitational strength of 100 newtons.
What is the relation you will use to answer this question? Mathematical formula, the law to find the mass from this information.
So we have the method of weight. Weight equals mass time gravitational field, right?
Gravity acceleration. So that according to this mathematical formula, the mass equal weight
D.
divide
Wait. So, okay, continue.
Okay. In this case, we will make a division. 7,600 divide 100. The result equal 76 kilograms. Okay.
Okay.
Okay. Ahmed?
An astronaut orbits the Earth in a space station, which is a vector quantity.
Yeah.
D.
The weight. Great. Excellent. Excellent. Of course, because mass, speed, temperature, all of these quantities are scalar quantities. But the only vector quantity of these choices is weight of the astronaut. This is question on the circular motion. Farah? Try to answer as you understand. Don't afraid from mistake. Okay, type. Who can answer this question as you like, as you understand?
Can answer?
Okay, Ahmed?
Which labeled arrow shows the direction of the resultant force on the satellite at the position shown? C.
C? Type. What is your opinion, Ibrahim? Do you agree with this choice? Ahmed, choice
Yeah.
C.
Yeah, let me see.
Yeah.
Also perfect direction. Well, yes, I agree.
Of course, unfortunately, you are wrong. Why? My dears, I said the direction of net force which acts. Farah?
Is it D?
Of course, D. Yes. We say the centripetal force. In this case, the centripetal force, okay, this is the net force which act on this object, which move in circular path. And we say the centripetal force acts on toward the center of the circle. Type, what is which arrows which represent the direction toward the center? D. Ahmed, do you understand this point? Ahmed? Ahmed? Ibrahim, do you understand?
Yeah.
Fine. If I ask you, Ibrahim, if I ask you about Bardo, choose the suitable vector or suitable arrow which represent the velocity of this moving object. Which letter represent the right direction of velocity?
Which direction of velocity?
Yeah.
Is it B?
B?
Hmm?
No.
Can I answer?
Ahmed, okay?
This time it's C.
What? Raise your voice, please.
This time it's C.
C, great, excellent. Why C, not A? Because the direction of motion, look at the direction of motion. This arrow indicates the direction of motion is clockwise direction. So that the direction of centripetal force and centripetal acceleration are represented by D. And the direction of velocity is C. Do you understand? All of you understand? Type. This is the question is very, very important. An object which travel in circular path at a constant speed. Which statement about the object is correct? A, it has a changing kinetic energy. B, it has a changing momentum. C, it has constant velocity. D, it is not accelerating. Who can answer? Who can answer? Make your think. Take 1 minute and tell me the answer. Okay. Anyone try to answer?
Okay.
Try it,
an
Ibrahim,
object.
try.
Okay, I'll give it a try. An object travels in a circular path at a constant speed. Which statement about the object is correct?
Farah. Try يا شباب. Try to answer.
It's not accelerating.
Is it C?
C
Constant
with
velocity?
all of you choose answer C.
No.
It has constant velocity.
I picked D.
D.
Yes.
Picked C.
What is your answer, Ibrahim?
C.
C. Okay. My answer is it has changing momentum. Changing momentum. Why? At the first, let me explain each choice why we choose the answer B. Number one, the answer with it has a changing kinetic energy. How come has a changing kinetic energy? If he told me this moving object to move with constant speed, يبقى never ever changing kinetic energy, because the kinetic energy equal half mass speed square. Do you know that? Do you know this formula to calculate the kinetic energy?
The momentum.
No, I ask at the first about the kinetic energy. when the examiner tell me this moving object to move with constant speed, this means this move with constant kinetic energy, because the kinetic energy equal half mv square. Do you know that?
Oh.
Ahmed, Farah. Okay?
Yes.
Type. Number 2, it has a changing momentum. It has changing momentum. What does the momentum mean? Do you know that? To calculate the momentum. Momentum, take letter P. This is linear momentum, okay? Equal mass times velocity. Okay? In this case, when the object moves in circular path, it has a changing velocity. So that when you multiply mass with the velocity, you will obtain the momentum. As the velocity change, the momentum, I mean, the direction of momentum will change. Do you understand that?
Yes.
Oh.
Farah, do you understand that? And Ibrahim?
Yes, I understand.
Yes.
Alhamdulillah, alhamdulillah. طيب. The third choice was C said it has constant velocity. We said constant speed, but variable velocity or changing velocity, because the object change its directions, all its path around this circle. يبقى constant velocity, wrong answer. D, it is not accelerating. How come isn't accelerating? As we say before, the moving object in circular path affected by centripetal force FC and centripetal acceleration. And we say both of them act toward the center of the circle. You understand? Please, before answer, try to read carefully before choose your answer. Okay?
Okay.
Yeah. This is the same question. Who can answer number 2? The object move in a circle at constant speed. Which statement about the force needed on the object is correct? Who can answer يا شباب؟
I'll answer.
Yeah. What is your answer?
The answer is it's D.
D?
D. Yes.
D. Okay. What is your answer, Farah? Farah? Ahmed, tell me about your answer.
B.
Please raise your voice. Huh?
B.
B, force in
Yes.
direction of the motion of the object keeping it moving in circle. Type, okay. What about your answer, Farah?
I think it's B also.
What do you say?
B.
B. Okay. The correct answer is C, not D, not B. Why? The question say an object move in circle at a constant speed. We said before, when the objects move in circle or in circular path, move with constant speed, but there is a force which acts on it toward the center called centripetal force. B said a force in the direction of motion. This means the direction of this force will change according to the position of object. Right, Ibrahim?
Right. Yes.
Okay, Ahmed, do you understand?
Yes.
يبقى B says in the direction of force change according to the changing of position. When the object مثلا at in the first quarter of the circle and they move to the second, the direction of centripetal force will change according to the direction of motion. But this is wrong, because all the time at any position of moving the object in circular path, the direction of force toward the center doesn't change. Okay, fine. C said the force toward the center of the circle. What is its function? Keep the object move in circle. The main function of this centripetal force here only keeps the object move in circular path. Don't forget, please. Okay? D, choice D, say no force is needed to keep the object moving at a constant speed in circle. How come? What is the effect, or what is the effect of any force which keeps this object to move in circular path? To say no force is needed. Do you understand, Ibrahim?
Maybe can you explain a little bit more of the reason?
Okay, look at this illustration. Pay attention, my dear. This is the center. I will draw the object at different position, like this, or this, or at this position, and in this position. Okay? I will indicate by drawing the direction of force or centripetal force, okay, at each position of this 4 position. هنقول ده A, position A, and this is position B, C, and D. Okay? At position A, the direction of centripetal force represented by this arrow. But what about the direction of centripetal acceleration? The same direction. يبقى دي F, C, ودي هنا A, C. يبقى the direction of centripetal force and centripetal acceleration toward the center of the circle. So what about the direction of velocity? Like this. Make perpendicular, هو perpendicular to the direction of force. Okay, I will change the color of the marker to indicate different direction. At position B, What is the direction of centripetal force? Toward the center. What about the direction of centripetal acceleration? Toward the center. AC, FC. What about the direction of velocity? Okay, طيب at position C, direction of centripetal force toward the center. What about the direction of acceleration? Toward the center. FC, AC. What about the direction of velocity? Perpendicular to this direction. At position D. The direction of centripetal force, the same, toward the center. But what about the direction of acceleration? Toward the center. AC, FC. The direction of velocity, like this. What do you conclude from all of these vectors? Ahmed.
Yes.
If I ask you, what do you conclude from this direction of different vector of centripetal force and the centripetal acceleration? All the time, at any position, the direction of centripetal force toward the center. كلهم ركزوا. All at any position. ولو عملتها هنا at this position. Direction of centripetal force toward the center. with direction of centripetal acceleration برضه the same toward the center. And the direction of velocity perpendicular to these two vectors. Do you understand?
Excuse me, teacher. Sorry, my computer has been literally frozen for too long. There's a problem with the network, keeps switching from no internet, so I'm returned.
Please, your voice, please, please.
Is my voice working?
Yeah, what do you say?
I said, sorry, I am sorry for getting disconnected because the internet has been keep switching, so I'm connected to other internet.
Oh, okay. Now, Ibrahim, now you understand the direction of centripetal force and centripetal acceleration?
Yeah.
Farah. Farah. Do you understand? I ask you one question only, and that is at the end of this session. Farah, the direction of centripetal force act toward the center or out of the center?
Center.
Raise your voice, please. والله مش سامعك.
It's the center.
Toward the center? Yes?
Yes.
Ahmed.
Yes.
Ahmed?
Yes.
What is the relation between direction of velocity and the direction of centripetal force? يعني هو parallel ولا perpendicular to this direction؟
perpendicular.
بس هو ده. I hope all of you understand that this is the main point in this session. Number one, the centripetal force This is the force which keeps the object to move in circular path. Okay. Second point, this force acts toward the center of this circular path. Number 3, the direction of acceleration is the same direction of centripetal force, which is toward the center of circular path. And the last point, the direction of velocity at any position of this circular path all the time perpendicular to the direction of centripetal force and centripetal acceleration. Do you understand?
Okay, understand.
Yeah.
Huh? Farah?
Yes.
Okay. I hope that inshallah, in next session, inshallah, we will complete our curriculum, okay? And my strategy in the class or in the session is illustrate part of our curriculum and apply by solving different questions from paper 2 and paper 4, and later, inshallah, from paper 6. I hope all of you understand me, okay? And inshallah, we will complete with us a next session to complete our curriculum. Don't afraid, we will complete in suitable date, inshallah, and we will answer great number of questions from all of these classifications, and after that we will answer past paper from paper 2, 4, and 6, inshallah, before your exam. I hope all of you are fine till next session, inshallah. أستودعكم الله والسلام عليكم ورحمة الله وبركاته. Goodbye.